Good day, viewers at home. I remain Engineer Will I Am plus S. In our today's video or class, we shall be discussing equilibrium of forces. What is equilibrium? Equilibrium is simply a state in which all forces acting on an object are balanced and the net force acting on the body is zero. So when all forces acting on an object are balanced, you say the object is in equilibrium. That is equilibrium of forces. So we have two ways of resolving equilibrium or solving questions on equilibrium. And you need to understand when to use formulas and how to apply the formula. So the first equilibrium we're going to talk about is that of rigid body. Equilibrium of rigid body. And the second we're going to talk about is equilibrium of non-rigid body. Equilibrium of rigid body and equilibrium of non-rigid body. For the rigid body, you should know how to use SOHCAHTOA. That is the basic trigonometrical ratio. The sine of an angle is the ratio of opposite to hypotenuse. The cosine of an angle is the ratio of adjacent to hypotenuse. And the tangent of an angle is the ratio of opposite to adjacent. You should know how to use this. And the next thing you should know how to use is how to apply sine rule. Sine rule. So in some of the questions, I will be using this. And some other questions, I will use this. I will be interchanging them, randomly. I will be using them randomly so that you'll be acquainted to how you can use either this or this. But remember, this can only be used to solve questions on equilibrium of rigid body. But for equilibrium of non-rigid body, you are required to know how to use the principle of moment. I'm going to state the principle of moment later. So you are required to know how to use the principle of moment to solve equilibrium of non-rigid body. Without wasting time, let's go directly to solve questions on equilibrium of rigid body. Okay, let us look at these questions here. The first question I have here says find the tension should be tension T1 in the diagram below if the system is in equilibrium. In brackets, acceleration due to gravity is 10 meters per second square. Solution. So what do I do here? Let me redraw the diagram the way it was. So I have this and this. So here was 30 degree and here was, let's say it was 10 kg. If you multiply 10 kg by gravity, you are going to have 100 Newton. That's converting mass to weight. So weight is mass times gravity. So the mass is 10, the gravity is 10. So 10 times 10 will give us 100 Newton here. So what do I do to solve the equation? Remember, here was our tension. That's what we're looking for, tension T1. Tension T1. So since this, our 100 Newton force is hanging downward, that is vertical, I can decide to say that this can also represent the vertical force. So here should be 100 as well, since it is vertical. Then since this is horizontal, I can decide to say that this should close up this to get that horizontal force, this horizontal. So here I have T1. So once I have this, the diagram can now be redrawn to give this. So here is 100 Newton. Here is T1 and here is 30 degree. So from what we have here, we only have opposite and adjacent. So I can use tan theta is equal to, what is the opposite of 30 degree? 100. And what is the adjacent? Sorry, not 100. Opposite of 30 degree is tan theta is equal to T1 over 100 because the opposite is T1 and the adjacent is 100. So what do I do next? Tan 30 degree. Since our options are in solved form, so I have to solve tan 30 degree in solved form. So what is tan 30 degree in solved form? Tan 30 degree in solved form is 1 over root 3, which will be equal to T1 over 100. So if I cross multiply this, I'm going to have 100 times 1 will give us 100, and this time this will give us root 3 T1 equal to 100. So that T1 will give us 100 over root 3 Newton. The answer is in solved form and was not rationalized in the option, so we'll stop here. So the answer to the question is 100 over root 3 Newton. That is how you can solve equilibrium of rigid body using SOHCAHTOA. Let's take another question. So the next question here says, in the diagram below, the value of the vertically suspended mass, value of the vertically suspended weight, W and angle X are, so we're looking for both this and this. So here is this, and so I can do the same thing I did in the previous example. So I have this. So remember, something was hanging down here. So here was our angle X. So since this is vertical, I can decide to say here should also be vertical. So the vertical will now be representing W. And since here is horizontal, let here also be horizontal. So here should be 3 kgf. And this man is already 5 kgf. So that is what we have here. How do we now find the W? Remember, here is hypotenuse. So I can say that 5 square equal to W square plus 3 square using Pythagoras theorem. So that W square will give us 5 square minus 3 square. W square will now be equal to what? 25 minus 9. So that W is equal to square root of 16. 25 minus 9 is 16, and square root of 16. So W is equal to 4 kgf. This is now the value of W. Then what of the value of X? To get my X now, I can use SOHCAHTOA as well. I can use SOHCAHTOA. So I can say sine X is equal to opposite over hypotenuse. So that sine X, sine of this X, opposite, which is 3, over hypotenuse, which is 5, which will be equal to 3 over 5. Sine X will now be equal to, if you divide 3 by 5, you have 0.6. So that sine inverse of 0.6 will now give us X equal to 36.87 degree, which is approximately 36.9 degree. That is how you find the answer. So in conclusion, the answer to the question becomes 4 kgf, that is respectively, 36.9 degree, which is option B. That is how you solve that kind of question. Thank you for watching. See you in my next class.